I'm just saying, you're trying. Matching different things with not just like. I knew what I was talking about. How to integrate. Over. I need like a. It's so simple. Yeah, I know that.
Okay, on the first question, did you get negative figures on the? Yeah, that's what I was in my final one. For some reason, so you just plug it in
Did you just say your algebra skills? No, algebra heads. Okay. So, do we have questions?
Yes. Yes.
I know you probably already answered this, but if we're doing a y-axis question,
Okay.
you know what I mean? And they end at the same point on the right, the graph, it's just like, how do
You mean they intersect?
yeah,
Okay.
how do we know which one goes first when we subtract?
You need to see a picture. Can you go to the board and draw me a picture?
Yeah. So.
So let's say it's a bad picture, but let's say we're doing the y-axis one, and don't we do like whichever one ends on the right?
So if you're going with respect to y,
Yeah.
and you're like I like to say, you're stacking those lines like rectangle or like library books, then you're going to go from the lowest y value to the highest y value. So on that one right there,
I know we could do the x.
that picture wouldn't work very good to do it with respect to y, at least the right side of that picture. The left side of that picture you could.
They end at the same point. So.
But that one right there, you wouldn't like. The reason this is bad. This is actually bad in both directions. You couldn't do this with one, because if you draw this rectangle from there to there, that's the same graph.
Yeah.
Same with right here. So if you were to do this with respect to x, you would have to break it up right there. You'd have to do, and if you were to do it with respect to y, you'd also have to break it up.
Okay.
This one right here, if you were going to do it with respect to y, you could, because you would just draw. You know, these rectangles are all the same, all the way up. So you would start at that y value and go up to that y value.
Okay, and let's say this is f of x and this is g of x. When you go to do your integral,
Those would need to be functions of y.
Okay. Fine. Which one would be first when you subtract?
Okay, so in that case, it's the one that's furthest to the right.
Oh, so this one?
Yeah.
Oh. Okay, that makes sense.
Which one comes first is either the one that's on top or the one that's furthest to the right. And that's going to depend on which way you're going. I thought I talked about that in the video. Did I answer that in the video?
Yes, you did.
Okay. Well, you said it. When you started your whole question, you said, I think you've already answered it. But it's okay to clarify. That's our job, isn't it? I think that's my job. So, I was just repeating that I said it because just I wanted to make sure I wasn't crazy. Other questions? I saw another hand.
There was a question with 3 functions.
So, what do you mean?
Like there were 3 functions and that they're in the center of all of them. That's the area you were going to find. I don't know how to subtract which one.
So if there were 3 graphs and you were trying to find the area like sort of bounded by all 3, there's no way you can do it with one integral. You'd have to break it up into chunks. You know what I mean? You'd have to do it as 2 separate ones, and then do like these 2 that make this side and these 2 that make the other side. What can you tell me what the region looked like?
I can tell you the 3 functions.
Okay.
Y equals 12 minus x. Y equals square root of x, and y equals 1.
Okay, so I'm gonna do this off the top of my head and graph this without a calculator. Is that okay?
Yeah.
So 12 minus x looks like this. Square root of x looks like this. And y equals 1 looks like this. Now I'm not sure where these all are going to intersect. So I got to think about this for a second. You know what I mean? Like, where's the region?
The leftmost intersection is at 1, 1.
Is this the region right here?
Yeah, that's right.
Okay. So let's blow that up just to make it a little easier to see. Does that help? Like, so I'm blowing that up. So this right here is what curve? That's the square root of x. This right here is y equals 1. And that here is y equals 12 minus x. Okay, so can you give me these points here? What's that point right there?
1, 1. The other one is 11, 1.
Okay, and then we need this one right here. Okay, we'll find it, but in a second. But do you see that I can't do that as one integral? If I'm going to find that area right there, then I'm really going to do this. I'm going to break it right there. Okay? Now, would it make sense to do this with respect to x or y here? And this, honestly, you didn't have to do this on many of these questions. They sort of told you what to do, right? I mean, they told you, do this with y, do this with x. But the next thing that we're getting ready to start, it's actually going to be helpful for you to think about that, okay? And when you answer that question, when you ask that question to yourself and answer it, you know, would it be smart to do this with respect to x or y? Think about drawing this line right here. Think about drawing that rectangle. If I draw that line there vertically, if I move through this region with that line, with those lines like that, and stack those lines up like library books, that's integrating with respect to x, right? That's adding them up with respect to x. Is the y equals radical x always on top of the y equals 1? Yeah, it is. Works perfectly, okay? Whereas if I try to do it the other way, it's not necessarily, okay? Now, I could do this. I'm going to redraw it again. So this is 1, 1. This is 11, 1. Okay? And do we know that point up there yet? Have you determined that? How could you find that point algebraically? Isn't that just where y equals radical x equals 12 minus x? So you could solve that equation algebraically. You guys know how to solve that algebraically? You're looking at me like, how would you solve that equation algebraically? Square both sides? I square that right? No, that's not right. That shouldn't be a 2x. What should that be? Mitter? 24. And then what would you do next? Move the x's and then solve that quadratic. Okay, what does it end up being? Did you find it? Are you using your calculator to do that?
I'm doing the functions and just the intersection.
Yeah. Oh, I'm just curious. I was just wondering. How many of you did that on Desmos? No one found that point? It turns out you don't need to, and you're going to see why in a minute, but we're going to go ahead and calculate it. So tell me what it is. Does everybody know what's going on here? Abdel, you said no?
Where'd you find that point, right?
Yeah.
I don't know.
Okay. Did you find it?
I know what it is. Is it 9-3?
Is it 9? I don't know. I mean, you guys tell me.
I know one of them is
It's
9.
9-3, yeah.
I just don't know.
It's 9-3? Okay, yeah. Square root of 9 is 3. 12 minus 9 is 3. Yeah, that's 9-3. Okay, perfect. Woohoo! Okay, so if we want to find this total area, right? One way of doing this would be to break this up into two separate integrals. I don't know if you can see the different colors there. But now on the other side of that vertical line there, we have a different curve on top, right? Whereas on this one right here, we have y equal x on top. On this one right here, we have 12 minus x on top. Everybody agree with that? So we could break this up into two. We could say it's this, the integral from 1 to, what did you say that was 9-3? So we could say it's from 1 to 9 of the square root of x minus 1 dx plus the integral from 9 to 11. Now which one's on top? 12 minus x minus 1 dx. Okay? So those two integrals added together will give you that area. But you could also do this, my friends. Look at this picture right here. I've cleared it. If we stack those rectangles like pancakes, and I draw this line right here, aren't these lines always defined the same way? The length of that line right there, isn't it always defined the same way? It's this minus this. This one's always on top, right? So we said that this equation right here was y equals 12 minus x. Agreed? If I solve that for x, that's x equals 12 minus y, right? And we said this equation right here was y equals the square root of x. If I solve that for x, it's what? X equals y squared. Agreed? Now, I could say this area is the integral of which one's on top, Megan? The one furthest to the right. 12 minus y minus y squared dy. And what are the bounds going to be? From 1 up to whatever that y value is right there, which is 3. Okay? This and this are going to give you the same number. Okay? Which one's easier? I don't know. They both require different kind of work. Right? The one on the right requires you to solve those equations for y in terms of x. I'm sorry, x in terms of y. Whereas if you just did it this way, you didn't have to do any solving, but you had to then break it up. see that? I mean, really, you should be able to do it both ways. Okay? Other questions? No. Costly. But what if we did this? Don't write this down just yet. What if you took this region right here? Okay? You took this region that's fenced in by these three curves, and you rotated this region around the y-axis. Did anybody describe what that solid would look like? Like imagine this region right here being rotated around the axis, all the way around. It's going to create a solid. What would it look like? Could anybody describe it? I'll draw sort of what it'll look like in a second, but what do you mean? Describe the cone.
Okay, it has a circle on the bottom and then a point on the top.
Like this?
Yeah.
He said, yeah, I haven't even drawn anything yet. Like that's a cone. Which I would say this cone, you could get that cone if you rotated that region right there around the y-axis. So you're changing your mind.
Yes, so it'll have a tinier circle on the top instead of a point, right?
Maybe. I'm not sure if I understand what you're saying. Adele, what are you thinking?
It'd be like a donut with like pointy.
Okay, I was actually, the way you just described that was actually what I was thinking. With a donut, it will be like a donut. But the sides of the donut will be like slanted, not curvy. Okay? And the inside of the donut will be like this. But there'll be a hole in it. Okay? If you were to slice the donut, like on its side, like perpendicular to the y-axis, if you were to slice it, like would you be stupid? Kind of like you would slice a bagel, you know, like that way. What would the slices look like? I agree with that. The bottom will be bigger slices and the top will be smaller. But what shape will they be? What?
Does it depend where you're at? Oh wait, yeah.
They all would have essentially the same shape. They're just going to change in size. They'd be rectangles? When you slice a bagel, do you get a rectangle?
It'd be a circle. It'd be a circle. Selling
But if you're looking at it like this, it looks like a rectangle.
Oh, well, yeah, I guess. If you're going to pick it up and eat it, like, what would it look like? It would look like a little miniature donut, right?
Yeah.
It would look almost like a, I mean, we call it a washer. You guys know what a washer is? A washer is like a disc with a hole in it. Anybody know what a washer is? Emmy's looking at me like I have two heads. Sometimes Emmy looks at me like I have two heads, and I don't know if it's because she thinks I have two heads or that's just her I don't get the whole expression on your face. What's a washer? You guys have seen a washer, right? It like increases the surface area so that you have a better like connection. Okay? But it's like a disc with a hole in it. So what would that washer look like? If I were going to do that, let's see if I can help you visualize this. Can you see the part of that washer? Now you're just looking at half of it. You're not looking at the whole thing. Okay, actually, let me draw another one in a different color. Well, I'll just draw another picture. It's too big. I drew this right here, and that right there. You see that? Could you think of that donut shape, the whole thing? Could you think of that as really just a bunch of those washers stacked up on top of each other? How thick are they? Like, how thick would these be? Well, you're saying it depends, right? I agree. But you can visualize that. Okay, that's great. Because you have to visualize all this stuff because I can't project any. My projector's not working. And so I can't project any like cool computer generated graphics for this, which we have lots of, but I can't project them because the projector doesn't work. So like I have to just go old school here and make you visualize this without that. And then you can play around I'll give you some links that you can play around and look at these. So what we're gonna do, like what we're doing now, okay, is what we call volumes of revolution. So that little thing there was just to help you start to visualize this. We're going to start with a much simpler region than what we just did. So there's a region, and I'm going to say that this region right here, that's y equals f of x. Okay, and I'm going to say that this is A, and that's B. Now I would hope, I would really hope that everybody in this room, if I said, write down an expression that would give me the area of that region, that everybody would be able to do it like that. What's the area of that expression? I mean, of that region. What's an expression that would give me the area of that region? Of
f of x minus 0.
Oh, interesting that Abdel threw that little 0 in there. Did you guys hear what he said? He said the integral from a to b of f of x minus 0. Because he said that's y equals 0. So he thought of that as the area between two curves. Don't need that minus 0, but I like it there. Maybe that's how we should just taught you that at the beginning, right out of the gate when we learned about integration. Just say, oh, that's just f of x minus 0, right? But it would true. I mean, you could just think of it also as just the integral from a to b of f of x, right? Now, what's going to happen if I take this region and I spin it around the x-axis? What's the shape going to be? Like a what? Like a flat dome? Okay. That's not at all what I was thinking, but I can see what you're saying. All of my shapes tend to revolve around food. Like when I say to visualize these, they always tend to end up being like food. Like I think of this as a cup, like just on its side. A cup. Or a bowl, fruit bowl. Yeah, I'll go with fruit. I like fruit bowl better, actually. Okay. I mean, it's going to look something like this, right? The x-axis. That's what it's going to look like, right? Now I turned it vertical. Okay. Now, can't you visualize this shape as a bunch of discs, if you will, circular cross sections that are sort of stacked up? Okay. So what would those look like if we drew them over here? Well, I'm going to draw this for us. I'll teach you how to draw these, don't worry. So if I just did what I just did there, and I draw a rectangle right here, and I rotate that rectangle around the x-axis, what's going to happen if I rotate that rectangle around the x-axis? I'm going to get one of those circles. Now, what I just drew there was just back half of it. You can draw the whole disk. I just drew like the back half of it. Okay? And maybe I'll draw another one over here just so you can see it. I'm going to draw it just thick. Okay, so there's another one. It's a little bit further down. Well, if I were to draw one of those discs over here, it would look like that. Just one of those discs, it would look like that, right? If I want to find now the volume of that cup or that salad bowl, couldn't we just sort of approximate that volume by saying, hey, let's just slice this into a bunch of these discs and then add those up? Okay? So I guess we need to figure out, well, what's the volume of something that looks like this? It's like a hockey puck. You know how to find the volume of one of those things? It's a little cylinder. What's the volume of one of these discs? Pi r squared times what? Height. So I guess we need to figure out who's who in this picture. I guess the radius would be like that, right? And this would be the height. Everybody agree with that? Well, what if I said, for this specific situation, I'm going to draw another one. What if I said that those discs were delta x. You see why I would call that delta x? Because that's like a delta x when we did area. That little rectangle there. What if I said that was a delta x thick? What's the radius of this disk? Like, what's the radius of this disk? Now, in order to figure that out, we're going to go back and look at this picture right here. Where's the center of that? Well, it's right there what the axis of rotation was. The radius of that disk right there is the distance from here up to there. What is that distance? Well, it depends on where you are. It depends on what x is, right? Like that distance right there is different than that distance right there. So can you write that radius of the disk as a function of x? What is it? Isn't it just the height of the curve? Isn't the radius, this distance right here, just whatever the y value is on that curve? Do I see that? So if I were to label it over here, whoa, way too much. I'm turning these on their sides. Everybody see that, right? It's just easier to draw that way. The radius of that disk is delta x, is f of x, and the height of that disk is delta x. So what's the volume of this disk right here? Abdel, what is it? Pi r squared height. But what's r? F of x. And what's the height? Delta x. Let's talk about what it is that we just wrote down. Okay? Let's talk about what it is that we just wrote down. What I just wrote down in orange there, that is the volume of one of these disks. It just depends on where you are. And how fat do you want to make it? I mean, you could, don't write this down, but if I just do this picture again, just so you can kind of see what I mean when I say how fat you want to make it. Like you could make a giant disk. You see what I'm saying? Like a really thick one. Okay? Talk to me. Yeah. Now, how good of an approximation of the volume would that be? Yeah. I mean, if you made the disk like the length of that entire interval, that's not a very good estimation of what the volume of that bowl is going to be, because that's just going to be like a giant cylinder that's b minus a tall, right? So you could say that the volume of that bowl is approximately equal to the sum of however many of those disks that you want to do, right? So if Del said, okay, make delta x really big and just add up one disk, right? But I feel like we have a way of doing this so that we could add up an infinite number of disks that are stacked like library books, that are infinitely thin. Like, what's a way that I could make there be an infinite number of disks that are infinitely thin? What needs to happen? What? Integration. Well, before integration happens, what causes the integration? What do I need to make really, really small in order for there to be an infinite number of really, really thin disks? delta x. If I make delta x really small, in fact, the smaller you make delta x, the better the approximation is. Adele said, make delta x huge and just make one giant cylinder, versus make delta x smaller, you get more disks. And if you make delta x infinitely small, you're going to get an infinite number of disks stacked up like library books. How do you make delta x infinitely small? What do you do? If we take the limit as delta x goes to 0 of this, that makes delta x really small, right? Infinitely small. Now, I don't know. This is hard to compute. I don't know what that, like, how do we set this up? Like, using a limit. Like, how do I take the limit of this expression, right? But we know what happens when we do a sum with delta x going to 0. What happens? Demi just told us. It's the integral. So what is that, what I just wrote down? What is that going to tell me? What's that going to tell me? The actual volume. It's going to tell me the actual volume. Okay? Remember when we started integration, I told you probably multiple times that integration is not really necessarily just finding area. What integration is adding up stuff. It's adding up an infinite number of things. Okay? What is it that we're adding up here? Okay? In this, when I write this down, what is it that we're adding up, really? We're adding up an infinite number of disks, compact, like, you know what a CD is? Think of a bunch of CDs, like all stacked up, like library books, lined up side to side, that are all changing in size. But we're in an infinite number of those that are infinitely thin. And when we do that, you get the volume, right? That's what's happening there. Like in, you know, if back when you learned about volume, you learned all those volume formulas. If you really think about those volume formulas, what they are is stacked area that's infinitely thin. That's what we're doing here. The volume is basically stacked up area. Okay. You want to put this into a specific problem? See what it looks like? So now the question is how do we draw these pictures? How much time do we have? 30 seconds? Are you serious? Oh, well, that's not enough time. Okay, so I think what I'm going to do is we'll come back to this Monday. This normally takes like 1 or 2 days to develop these ideas, and then as soon as you see it, it's like this is the easiest thing that we do all year. Okay. What I think I'm going to do today for you to do over the weekend is I'm going to create a Delta math assignment that's just practicing with more area and stuff. Okay? We can't do Delta math on this yet. That's crazy. But I'm going to put that on. I'll put that on Classroom this afternoon. I knew we weren't going to get through this. It's going to take some time. Gotta go slow.
Yeah.
What?
Oh,
That's actually sort of
I got confused when you drew like the half circle like that because I couldn't like see it. But then you drew it over
but you'll
here.
see it when we draw it, like when I can give you a graphic. Like I gotta get my projector.
Yeah.
It's gonna be so much easier. I don't know how, I did, well, I did. Hello, Mia. Nothing. You sharp? Oh, I got Yeah.
And except the lid was like too big for the cup, so I had to just chug it in the library. So it was like spill everywhere. That's kind of. Because I don't carry an open cup.
I'm doing right now. Is everybody here? Oh, we're just missing Nicole, I guess.
It's our little class, our little people. Samuel's not here.
Oh, yeah, no, Samuel's not here. Where is Samuel? Oh, I think you told me he wasn't
I forget why.
here. Oh, he's here.
Who's
He's walking in now.
What? Samuel. He's walking in right now. That's Samuel.
You guys have questions on
No.
Yeah. You have a question? You Lay it on me, string bean. Yeah, you're gonna have to tell me. Well, actually, no, you don't. Because I have a book right here. What's number? 15? Oh yeah, there's some person you don't know what to do. Like, so the three curves were y. Wait, we're not doing volumes of revolution yet, so let's don't get confused. So the three curves were y equals 12 minus x, y equals square root of x, and y equals 1, yes? So if you graph those babies, maybe you need a Desmos to do that. But the square root of x looks like this, 12 minus x looks like this, and y equals 1 looks like this. So we're talking about this region right here. Okay? So now I'm going to erase this. Okay? Maybe we'll blow it up too, just to make it bigger. Okay? Did the bell not ring, or it's like social hour out in this hallway? These teachers. It's a ruckus out there. Okay. So, how do I deal with this with three curves? Which one's on top? Well, if you're looking at this and you're thinking about doing this with respect to x, okay, doing this with respect to x is really like stacking rectangles like library books side to side, right? So right there, it looks like radical x is on top, and this y equals 1's on bottom, right? But hey, something happens. Something happens right here, right there. It switches. Something else is on top, right? So if you're going to do this with respect to x, you've got to break it into two separate pieces, two separate intervals. Okay? Well, it might be helpful if we have these points here of intersection. I think this one is 1. Is it 1? No. What's this point right here? Is it 1, 1? Yeah, it's 1, 1. Yeah, thank you. I'm not on crack. Okay, and this one out here I think is 11, 1. It's not?
I was saying I would hope not. You're not on crack.
Oh, no, I'm not on crack.
You probably
Shouldn't say that? Well, yeah, we're live, but why is it okay to say I'm not on crack? Like, I'm not. That's probably a good thing that I'm not on crack. It would be much different if I, you know. Okay, so here, we ready? So if I'm going to do this with respect to x and stacking these up like library books, do you guys understand what I say stacking like library books? I mean, I don't even know if you know what a library is. Like, you go to our library, there ain't no books in there. Okay? But if I'm going to do this like that, I'm going to go, okay, this is the integral. In this first chunk, it's going to be from 1. Oh, we need to figure out, well, what's that right there? What point is that right there? Where those two intersect. Now, you can algebraically find that. It involves solving a quadratic equation. I mean, where these two intersect, that's where radical x equals 12 minus x. And that's a quadratic equation that you have to solve. Because Square both sides, you get x equals 144 minus 24x plus x squared. And you solve that quadratic equation. Okay? Or you could have just graphed it in Desmos and found that it was 9, 3. Okay? So this is 9, 3. Right? Are you guys just agreeing with me? Jimmy, you're just agreeing with me? No, you're not? Okay. So you understand where 9, 3, like 9, 3, what that is? I mean, if you plug in 9 here for x, what do you get? 3. If you plug in 9 for x, what do you get? Oh, okay. So we're going to integrate then from 1 to 9 of which is on top? Square root of x minus 1 dx. And then we're going to add to that, integrate from 9 to 11. Now which one's on top? 12 minus x. Minus 1. Okay? And just compute those two. But, my friends, you could also do this problem with respect to y. You could stack those rectangles up like pancakes. And if I stack those rectangles up like pancakes, which one's on top? On top. The line, right? This is 12 minus x. And this one's square root of x again, right? But the thing is, if I'm going to stack those up like pancakes, and I'm going to integrate with respect to y, then I can't use 12 minus x. This equation right here is y equals 12 minus x, right? And this is y equals the square root of x, right? What I have to do is rewrite that and say, oh, then x equals 12 minus y. And then what's this one? X equals y squared. And now, Nicole said this one's on top. But we're going to call that 12 minus y squared. And we're going to add those up from 1 to, what's that y value up there? 3. Okay? These right here will give you the same number. Okay? Which one's easier? Which one's easier? There's not a right answer to that, friends. They both require additional work. If you do the left side, you got to find that middle point and break it up into two separate ones. If you do the right side, you got to solve those things for x in terms of y. Okay? You really should be able to understand it both ways and do it both ways. Set it up both ways. You could also make the argument which one might be easier based off of what the antiderivative is. If you actually physically had to compute it, which one's easier? I'm going to say this one. If I physically had to compute it, I'm going to say this one's easier. Why do I think this one's easier? This is Scott Mitter. Why does Scott Mitter think this is easier?
You don't have to deal with the third.
No radical. Screw that radical. We don't want that. Nobody wants to deal with a radical. This is cute little y squared. Y. Easy antiderivatives. Okay? you throw a radical in there and then everybody's head falls off. Questions on that? Does that help Nicole? Alex talking.
So for these problems, will we have to compute it with like by hand, or will we always use a calculator?
It's, I mean, you're gonna have to do some computating. Computating is the word. Computing. You're gonna have to do some computing of them by hand. But you're also just gonna be setting them up a lot too. I mean, honestly, the work here in like the calculus is really gonna be the setting it up. I mean, that's where. Other questions? Yeah.
It didn't seem like they really had like material set up on like a graph bit, and then I didn't know what to do.
Because you didn't know what the region was.
Yeah.
Okay? So the key when they don't give you the graph and they give you those equations like that, okay? Now they're telling you for x in 17, they're telling you over x equals -1 to 1. So that's basically telling you then between those two bounds. Okay? If they don't give you that and you make the graph, then you've got to make a decision. Like, I'm just going to draw a picture here just so you can. Okay? I know that may not be what it was, but if you graph something that looks like that, if they tell you the area is bounded by those curves or those equations, you've got to find the region where like it's fenced in by those curves. Okay, so this would be the part that we're talking about. We wouldn't worry about all the other stuff. Okay, so the first thing you're going to want to do is look for intersections. Start there. And then see, okay, is there a region that between these two intersections can I fence in an area? And if you can, that's it. You probably made a mistake. Which one are you talking about? Well, since you probably did this on Desmos, I'm gonna do it on Desmos so I can see exactly what you saw. I can't put this up there because I don't have a projector that works. So it's y equals x cubed. And what was the other one? Oh. You gotta write that down. When you guys are doing your homework, you gotta write down that stuff. X squared minus 2x. X squared minus 2x. Okay, but so, Nicole, on this one, they said between x equals -1 and 1, right? So the two graphs look like this. The two graphs look like this. Right? But they told you between x equals -1 and 1. So you're going to go from here to there. So again, we're talking about this area and that area, which tells me you're going to have to switch it. Because on this first one, the parabola is on top. Over here, the cubic is on top. So it's got to do it as two separate intervals. All right? So what you're going to do is go from -1 to 0, because that's where they intersect, and then from 0 to 1. Does that make sense? Other questions? Yeah.
I remember, I feel like this was back in like middle school, but I remember there being like a setting on the TI calculators where you could like fill in all of below or above a graph.
There is a way to do that. I can't remember it. But I don't remember off the top of my head. If you gave me 5 minutes with the calculator, I could tell you. But, I don't know what the advantage of that is. Is that? I
mean, just so you can see where they line up, I guess. I don't know.
But what do you mean where they line up? All we care about is who's on top, right? I mean, that's really all we care about here. So you don't have to necessarily fill it in. And shade it, you mean? Like you're talking about your shading? Yeah.
Okay.
There's inequality settings that you would have to use to do it.
Yeah, it's when you go, what you do is you go to, here, you go to like where you, how you choose the color, you put it out.
Yeah, shade above and shade below. What else? How come none of you have anything out except Nicole? I'm just curious. Like, why is it that everybody in the room just sitting here like, you already know all this, we're good to go? Like, yeah.
I set it up, I jacked it, and there's like two unshaded areas, so I knew I was gonna add them together. But I thought maybe I had the wrong bound, but I kept getting a negative number for my answer. And I know we're not supposed to get a negative number.
So, let me look at this here. So 21, x equals 2y.
Yeah.
And then
X equals Y
cubed minus y. Okay, so the goal I see in this picture, you're going to have to do this as two separate intervals.
Yeah.
So your first one's going to be from negative 1.7
to 0.
up to 0 of y cubed minus y minus 2y.
Okay. I think that's what I did.
If you reverse them.
I had it reversed first, and then I switched it again.
Okay, so it should be that way. And then the next one's going to be from 0 up to 1.7 of 2y minus y cubed minus y.
That's what I did.
So my guess is you did one of two things. You reversed it when you calculated it, or when you did the minus on the second one, you didn't subtract, you didn't distribute the negative.
Okay, do I have to?
Absolutely.
Okay.
I mean, it's this, kid. X cubed minus, or sorry, 2y. It's 2y minus y cubed minus y.
But if I have that parenthesis.
Right? Well, if you have that parentheses there, and you're doing it on like Desmos or a calculator, then it's going to do it for you.
Maybe I didn't put the parentheses.
Yeah, I mean, otherwise you've got to distribute it. Yeah, you won't get a negative answer. Anytime you do area, like between curves, you will not get a negative answer. All right, other questions? Okay, so let me ask you this question. See if we can visualize something. Since I can't project anything, we're going to have to go old school here. That region that we just had, I'm going to start with that. That region looks something like this, I believe. Right? If you took that region, just that region right there, and you rotated that region around the y-axis, So like you took this region right here and rotated it around the y-axis and created a solid. What's that solid going to look like? So think for a second. Don't say it out loud. Think for a second what that solid might look like. What do you think? I heard, Alex, you said something. I thought you said like a donut? Describe the donut.
It's slightly different on one side than the other, but the overall circular shape of the hole in the center is why I said it.
Okay. So there's going to be a hole in the middle. And you said slightly different on one side.
It'll be flat on the bottom, and then the outside will be just a straight line.
Like a straight edge?
Yeah, and then the inside will be sort of curved.
Curvy. Yeah. Huh. If you were to slice that donut like a bagel, you were to slice that donut like you know what I mean by a bagel? Like slice it perpendicular to the y-axis. And you were to cut off a piece. What would the piece look like?
So you want the bottom piece or the top piece?
Oh, so you're saying it's not going to be the same? Well, the very, very top, there won't be a piece. Right? What would it look like on the bottom? Yeah, like a bagel.
What's it called where it's like two sides and then the two sides go in? Trapezoid. Yeah, like kind of like that. But the inside of the trapezoid is
I think you're slicing it the wrong way.
I might be.
At least what I'm thinking. I'm thinking slice it like this, like a bagel.
I think from a top-down perspective.
What?
Are you talking about from a top-down perspective?
I mean, like when you pick up the piece that you sliced off, what's it going to look like? That you're holding. You're going to be like holding this.
But are you looking at it from the side or from the top?
I want you to describe it three-dimensional.
Oh, well, it's gonna still have a hole.
It's going to be like a bagel, right? Or it's going to be like a disc with a hole in it, right? Everybody agree with that? This vase. Can you see this vase could have been generated by taking a region that looked like, well, I'll just draw it. That looked like this. And rotating that around an axis. You see that? If I take this vase, okay, I'm holding this vase like this. I'm holding this vase like this. Now let's pretend that this wasn't glass and it was actually like made of cheese. Okay? If I were to slice that vase, slice off a piece of it, what would the slice look like? Just a circle. It'd be a little disc, right? And like the size of the disc, the size of the circle here versus here might be different. Like this is a much bigger piece of cheese than this one, right? If I were to go back to this picture here and I were to sort of try to draw, that was ugly. if I were to draw one of those slices, it might look something like this. You see that? You're only looking at half of it. Okay, not the whole thing. The other piece, the other part of it would be coming out at you, but that's hard to visualize. So that piece right there that we just drew is like a washer. How many of you know what a washer is? Really, you all know what a washer is? It's like a little piece, a little metal disc with a hole in it. But could you visualize this solid that we were talking about, like Alex's donut that he described? Could you visualize that as really just a bunch of those washers stacked up like library books? Just like you could visualize this vase as a bunch of did I say stacked up like library books? I meant stacked up like pancakes. Just like you can visualize this vase as a bunch of circular discs stacked up like library books side to side that are changing in size. You see that? Huh. Okay. Well, let's go with this picture right here. Let's say that this is y equals f of x. Let's just say that's some, I don't know the equation, but let's just say that's what it is. And this is a, and that's b. Okay? Everybody in the room should be able to write me an expression right now that would tell me the area of that region. If you can't do that, then I probably want to hit you with a 2x4.
I will put that.
Oh, grab it, yeah. Now, I'm not going to hit you with a 2x4. I would just want to. What would be an expression that would tell me the area of that? Gavin? I'm going to pick on you. Because Samuel always answers all of it. It's like these three people, and then occasionally a Billy. So tell me an expression that would give me the area of that. It is what you're thinking. It's not hard.
The integral
Right.
from
The integral from
A to B
A to B of
y equals
f of x. I mean, this is the, it would look like this. Don't be nervous. F of x. Right? That's the area of that. Okay? Fine. Now, if we rotated this region around the x-axis, we're going to make that base, right? So that's going to make a vase that looks something like this. Well, you already know what it looks like. I don't need to draw it. But now what I want to do is, my goal here is I want something that's going to give us the volume of that vase. Okay? Now, could you just think of that vase as a giant, as a giant cylinder? I mean, you can think of that. Now, I mean, you can approximate the volume of that vase as a cylinder that's this tall, right? Like, you know, just a big cylinder. Let me see if I can draw that. Right? I mean, you can think of that. This is a big cylinder. Not a very good approximation, though, right? Could you think of it, though, also as a bunch of cylinders stacked side by side like library books. Follow what I'm saying there? And if I drew a cylinder on its, like one of these cylinders like this on its side, it would look kind of like this. Like a little disc. It's the circular piece of cheese that we were talking about. What's the volume of one of those guys? What's the volume of a cylinder? We know how to find the volume of a cylinder? It's pi r squared h. Well, I guess we probably need to label something here that would be h, and that would be r, right? But if you're looking at that vase, the piece of cheese or the cylinder that we're talking about is changing in size depending on what x is. What do I mean by that? This disc right here and that disc right there are not the same size. Agreed? So could we write an expression that's going to give us the volume of one of these cylinders that depends on what x is? Okay, so let's do that. If I draw another one, and I'm going to say, instead of calling it a cylinder, I'm going to call it a disc. What is going to be the volume of one of these cylinders? Well, what's the radius of that cylinder? What's the radius of this red one? Isn't it just however tall that is? What's the radius of this orange one? Isn't it just however tall that is? Well, what determines how tall that is? The what? The y value. And how do we get the y value? F of x. The radiuses of these various cylinders are the f of x values, right? So the radius of this is f of x. Now, what's the height of that cylinder? Okay? Well, guess what? I get to decide what that is. I can make it as fat as I want. Okay? Or I can make it as skinny as I want. So what I'm going to do is I'm just going to call it delta x. It's going to be the height of that cylinder. Yeah. Oh, yeah. So what's the volume of this sucker now? It's still the same thing. Billy, what is it? What's the volume now when I have the radius and the height different? Okay, so it's important what we understand what it is that we just wrote down. What is it that we just wrote down? What does it mean? This right here is the volume of a slice of this vase that we have decided how fat it's going to be. Okay? And it depends on how far in to the vase we are. So if I'm looking at this vase and I want to slice one of these, like the volume of the slice that I'm going to cut off when I cut off the piece is going to depend on how far I am this way. Okay? So what could we say then the total volume is going to be? Of the vase. Well, wouldn't that just be, well, just add up all of those volumes? right? How many do you want? 1? You want 10? Doesn't matter. But the total volume of the base, this is still, friends, an approximation. How do you make the approximation better? More discs. More discs. Thinner slices. Same thing. So do we have a way? Well, before I ask this question, let me ask this question. Yes, we can make the approximation better by making more discs, thinner slices. How can you make the approximation perfect? What needs to happen? How big do the slices have to be? Or I should say, how small do the slices have to be?
Infinitely thin.
Infinitely thin. We have a way of making that happen? What do we need to do to make those slices infinitely thin in this situation right here? What needs to go to 0? What tells you the thickness of the slice? Delta x. So if we take the limit, the actual volume of this baby is going to be the limit as delta x goes to 0 of what Billy just told us, pi f of x squared delta x, right? Now, I don't know how to do that. And I don't think you do either. But there's a way around this because we learned what happens when you do a limit of a sum as delta x goes to 0. What is that? That's integration, people. That's what integration is. Okay? This is actually equal to the integral from a to b of pi times f of x squared dx.
Find a rectangle with the equal volume to what would be underneath the curve. And I got that out of the integral from a to b of dx. And I squared that and put it in pi. Or it's actually, never mind. I messed it up. I did something like that.
Oh. So you found your own mistake. I like that.
Yeah, because it was a to b over b minus a, and then that should be all b squared, and then that should be multiplied by.
Oh, and so it doesn't work out. Okay.
B minus a. You got it, well, you got it.
So remember when we learned about integration, when we first started talking about integration, I said to you on multiple times, you have to understand that integration is not finding area. Integration is adding up stuff. It's adding up an infinite number of things that are, well, it's adding up an infinite number of things. I mean, that's what it is. What is it that we're adding up here? When I write this down, what is it that's really being added up? Yes, but tell me more. It's an infinite number of slices, but what can you tell me about the slices? That are infinitely thin, and what else can you tell me about them? They're specific, they all have a specific shape. They're circular slices, or discs, circular pieces of cheese that we're adding up. And the radius of those pieces, those radius of those slices is determined by what? Where you are in the base. And what is it? What is the radius? The y value, the f of x value. Okay? This right here, that's what you're adding up. Okay? When I took Calc 1, or sorry, Calc 2, when I first time I went through this class, when I was your age, high school. And I probably would argue, even when I took it the second time in college, I never really learned this. I never really understood that integration was adding stuff up. Because I was taught integration was area under a curve. And so every time I would look at this, I tried to think about this in the context of area. It has nothing to do with that area under the curve. That expression that's written there has nothing to do with the expression that Gavin gave us at the beginning. Okay? That expression right there, this expression right here, has to do with adding up a bunch of infinitely thin disks that are stacked up like library books from A to B. Okay? What time do you get at? Like now. So this is what's going to happen. Like, we're not ready to try problems on this yet. This typically takes like about a day and a half to like develop all of this. And then this is going to become one of the, like, you're going to think this is the easiest thing that we do all year. But it just takes about a day and a half for you to get there. I'm going to create a Delta Math assignment here in about 10 minutes that I'm going to put on Classroom. It's not going to be very long, but I want you to do for the weekend. That's going to be dealing with area between curves. Okay? Just to give you more practice with that. That's also going to check. It's also going to give me a check as to whether or not you really understand that. So if you don't understand how to do those lengths, you know, if you can't figure out who's on top, who's furthest to the right, and find the length of those things, you're not going to be able to do these problems. Because those lengths are really important in calculating these volumes. Because those lengths are going to turn into the radiuses of the disks. Okay? So that's all. Checked out for math. That's going to give you the average of the function. That's going to give you the average line.
And when that multiplied by gives you the rectangle area.
I don't know.
Like, if you multiply this by B minus A, then you're just getting the actual area.
Which is the area. So if you were to treat this these separate terms of treat this as a radius and treat this as a height, you get a rectangle. You get the same area, right?
I'm not sure if I'm following.
So like, so this is gonna give you the out. This is gonna give
I have
you the
nowhere to put
You
that.
can stick that in your bag. I don't want that thing.
No, I'm getting it at the end of the day. I don't want to take a crush.
That's so funny that you brought that in here because as soon as she handed that to you, somebody out in the hall was like, she's gonna turn around and take that right to you. I think it was Mr. D. She's like, she's gonna turn around and get that
I'm
right
gonna
back to
be
you.
around all day.
That would be like
Crush.
Yeah, it's fine. I'll just stick it in my bag. Okay.
Well, don't crush it.
Which would be the height of this one, and then this would be the outer radius, or that would be the radius or the base of this one. And then I get square this. And then you get the integral of the f of x dx squared over b minus a squared minus b minus a pi. So you get the integral of dx squared over b minus a.
These aren't, that's not equivalent to that.
It's not?
No, because this right here does not equal this.
Oh,
Okay.
These aren't equal.
Yeah.
following me?
Yep, yep. Take care of that.
No.
okay?
Will do.
It means all the difference.
Is that a thank you, a thank you note?
What?
Is that a thank you note? Or like telling them to write a thank you note?
Yeah,
I was gonna do that.
well, I got gave them the address and the email and everything. They're gonna email them today saying that they met John last night and that expect a short note soon.
Well, you don't, why would you email and say I expect a note?
Because just something along that line, but, because they're not at home.
Who's not?
The Hales do not live in the house in the winter. They live in the house on Marco Island. So if you email them, then they know to look in the mail for the letter. So that they're not like, oh, we just gave thousands of dollars and we got no response.
But I don't have the right to deal with the entire function.
Coach?
Yeah.
If that over, or a few minutes, takes me by. Not, like what you have to put up there, to do my,
Scott, if you think that's tactic, tell them.
That makes sense now.
Yeah, I'm just saying
I was thinking like if they were like living down the street, they get an email and then 2 days later you get a note. Like,
no, yeah, they're.
I'm not sure.
well, they're not algebraically, I mean, you could just do the algebra and prove they're not the same. I think what you need to do is the visualization as to why they're not the same. I have to think about that for a minute. I can't do that off the top of my head.
Yeah. So like if I were to have a rectangle of equal area to the area underneath that curve, and then make
The area of that rectangle has nothing to do with the volume of that solid. They're not
okay.
Like you're thinking about this vase, right?
Yeah.
And you're trying to come up with some, and you're using the area under this curve as a basis to find the volume of this solid, right?
Yeah.
And you're trying to figure out what.
Well, in a way, I was using it to find. I was finding a rectangle as an equal area to the area underneath that curve, and then using that
To make a cylinder.
Yeah, using its height and its
But
radius.
so then you're trying to create a cylinder that has an equal volume to this,
Yeah.
because you found that because you found the area of the rectangle that created that cylinder, but that's not going to be. I don't think that's going to be the same. No. I think we got to figure out a way to help you visualize that.
I think I was doing something about like may not be true. I think thinking as long as the volume of that height of it is equal, and that's rotated equal, but I guess that might not be true.
Right. I need to figure out a way to help you visualize that.
So I'm kind of thinking like I don't know.
Like just because two shapes have the same area and you spin them around the axis. Like I don't know that necessarily that means that resulting volume is going to be the same.
That's what I should call that.
Yeah, and I have to think about that.
Because how I always think of it is like if you were to like cut off a slice of part of it and fill it into the gap to bring it to that cylinder and bring it to that shape. And I would think that it would work, but it may not. Or like if you want to like melt it. Sometimes how I visualize like when you're trying to like convert like a curve into a shape with the same volume, where it's like some area under a curve to rectangle with the same volume, melting it, cutting it.
Yeah. I got it. Wow.
I don't think that's it.
Dinner, I have a question. How do you integrate negative cosine of negative cosine x?
Don't.
You don't? So what is it? 0?
You need the antiderivative.
Yeah.
There isn't one.
Okay. That's troubling.
Why? Did you get that on something?
Yeah, I was,
My guess is you're missing part of it.
what?
If there was a sign floating in there, you could do it.
No? Yeah, pretty bad. I was integrating some crap from the homework. Do you know how much the scholarship is?
I think it's 1,000 a year. Heck, good.
That's pretty good. That's pretty nice.
Yeah, I think that's what it is.
Damn.
But it's thousands.
Mm-hmm.
It's not hundreds.
Yeah. That'll help me a lot. Whoa. Damn. Oh, so you know that Hawaii school I was talking about? Mm-hmm. Well, I got 20 grand per semester, so 40 grand each year, which gets you the tuition. Holy shit. It's like $100 below the tuition. But the room and board's like 50 grand. Oh my god. Well, for 50 grand for 4 years, but still. Yeah. The room and board's way more than the tuition. So, gonna have to work on that. Also, room and board for like 50,000 when it's like a crappy mattress and a shared bathroom seems ridiculous. And food. I don't know. I feel like the food is mostly, especially in Hawaii with that. Yeah. I'm excited about UC's meal plan because it includes like the restaurants that they have on campus. Oh, that's cool. So it's like not just like food from the dining hall, like also like the subway on campus. I can go and get a sample for food. So it's not free, I only pay. Still. Wrong bragging. I don't actually go that food. Yeah. I thought about applying to Hawaii Stone School, like the University of Hawaii. Pretty good. Maui specifically. Its film program is insane. Like, they employ the students, like, straight off the bat, like, you work on the show Hawaii Five. And you make up, like, half the crew. Like, I get an appointment, then literally everything is fine. Like, not for that, like, good for it. And, you know, if I don't, I'm pretty behind in the other college department. So, I know. I know. Oh god, I don't know. If they don't accept you, that is so stupid. Well, no, it makes sense. Because it's not necessarily like if you're the best application for somebody else's exact community. I still think you deserve special treatment. Oh, thank you. I asked you last night what senator endorsed you, and I have no idea. Oh, it was from the Congress.
checking my email about that, because they're supposed to post, like, if you get offered something, they're supposed to post it to your portal, like on Fridays or something. And I keep checking my email as if it's gonna show up there, and it's not.
Wait, what do you mean if they offer something?
Like, if they offer admission, they like usually do that by Friday or something.
Yeah, because the boards meet every Thursday.
Or apparently they meet every Tuesday
Oh.
or something. And I got a nomination from Turner and then from Brown.
Mhm.
And okay, I haven't like started telling people, but I got a vice president nomination.
Really?
Yeah.
That's crazy.
I
Oh yeah,
swear,
really?
if I get 3 nominations, it's still don't get it.
But so you heard back, right? You're on the.
I haven't heard back that I didn't like get anything from them that said I was on the wait list or anything.
Mhm.
But my like local representative or whatever
Right, I know her.
she said that like I was on the wait list.
Mhm.
I don't know if they would have told me or whatever.
I feel like she tells you first because it comes in snail mail. So you probably get like a packet.
Yeah. And it was weird because the vice president nomination didn't show up until like last week
Oh,
for whatever reason.
that's. I don't think.
I don't know when they picked those.
I was gonna say when they your portal does not show like when the academy got it. First, the portal is like the last step. So I know that my portal has like a receive section and then like an approve section. So the receive would pretty much immediately be checked, and then it would take like months for it to be approved or whatever.
Yeah, they didn't tell me
Really?
at all until I like saw it. I had to ask my field director if that was like a real thing. So I'm like the first one to get it in this area since she's been working with it.
Well, I think.
Dude, that's awesome. Congratulations.
Yeah, and okay, just because like the waitlist for that kind of school is different than normal school, you know?
Yeah,
Because
It's not like a regular wait list. It's
Right.
just like everybody goes on it and then they just take people off.
yeah, which is so horrible. It's so mean.
And then by May, you still haven't taken off. You're on like the classic wait.
Yo,
And
I didn't get it.
Oh, I'm sorry.
That's okay. There was a scholarship mailing that came out for a scholarship I applied to my mom.
at least we got this.
Yeah,
I did you hear? Yeah, did you hear how much it is?
come on.
It's like $1,000 per year. Yeah.
Yeah. Not bad.
But yeah, the way they like toy with your emotions for the academy is horrible. Like, although the date for us, when she hear by is April 15th.
That's like straight up gaslighting.
Dude, it
Putting
is.
you on the wait list and then being like, actually, no.
Well, it's not just that they put you on the wait list and then might accept you normally, but also a ton of people will turn down their appointments like at the last second. Because the school like this, it's such a big commitment that people like back down at the last second.
And a lot of people are like, well, I'm gonna apply to this, and if I get in, I might go.
Right.
But if I get into like this other school that I actually really want to go to, I don't know.
So even
I
if
can't imagine not having the academy as my first choice, and it's weird for me.
There could be people who applied to all the academies and
Yeah, but
then got into them all. There could be.
Evan overalls are kind of the Navy and Air Force. No. You got an Air Force and Army.
yeah, to get 3, you would have to have 3 different nominations that go to 3 different schools, and then you can do one
Dude, that kid is insane. He got like a letter of
assurance.
yeah,
What's that
like
mean?
It means you got like a 36 on your ACT, and they want you in the academy, and they're just gonna tell you that.
in like October he got it.
Really?
Yeah.
And you're supposed to tell your nominating source so that they don't not take you or something like that.
Yeah, they like have to nominate you. Or they just will. They're like, oh, you gotta like do this.
Maybe you should drop that 36.
Yeah. Well, he's not even just that. I mean, he was like,
No.
yeah, I know, but he was like state wrestler, like valedictorian, I think. Yeah.
read somewhere that usually you don't have a 36, you probably won't.
Yeah,
Really?
that's like the turning point.
Yeah, like after ACTs are done, I don't think they get them out anymore.
Oh, okay.
Definitely not get 36 in ACT. And my crappy ACT score went in long before my good ACT score went in. So that was so annoying. It took forever to process. I was sitting there and it was like 27. I was like, that is not my score.
What was your better one?
32. I got a 23. I mean, it doesn't actually matter.
Yeah.
It's
You already
literally
got
testing.
into college.
Yeah. Not valuable.
I'm
score
already
though.
going somewhere, so.
Yes, you can laugh at Joe with that.
What?
Uh-huh.
Oh, yeah, facts. Hey, I got in a couple of schools, and they've been like, my admission counselors have been, harassing me about, do this, don't forget to sign up for this. And I'm just like, one of them called me, and I called and I answered, and I was like, I don't actually want to go to your school. If I don't get accepted to my first school, can I talk to you then? And she was like, yeah, that's fine. So stop bugging me, and she actually did.
Really?
Yeah.
I don't want to do that to UD or whatever because UD's because the ROTC guy at UD, the whatever who runs the whole thing, sent me a congratulations email for getting the national scholarship, and he's like, when you come,
Yeah, they always do that.
When you're
Once
here.
you're here. Yeah. I mean, the deal is though, I already got money from them, and I already got accepted from most of these schools, so I don't really care what the admission counselor thinks of me. So if I need them, then I'll go
I
back.
also interviewed with him for the scholarship, so I talked to him.
So you don't want to
He
be
was
like,
like-
actually, I don't want to go there.
He went to West Point, and I'm like, I asked him a little bit about West Point too. He's like, yeah, but you should go here. So I'm like, not really. But he was like, he definitely wanted me to want to go to ROTC instead.
I do not get that. I feel like RC is definitely not good.
He said it was a different kind of experience. If you want to go whatever.
Like it's like
I would
half
imagine it's-
civilian and half.
It's probably more similar to the regular college experience.
Yeah.
So people
That's the
might.
thing. It's like half civilian, half military. Whereas the academy, they're entirely military. Or you can get 4 hours of civilian life on a Friday night, maybe, if you're good. For freshmen, it's so bad. You never leave.
Sounds like you're gonna have a great time.
Yeah, but I'm also planning on being one of those kids that everyone hates, who gets all their work done and goes to bed at 9 every night.
You plan on?
Yeah. I feel like I can do it. I can't. I mean, technically, you're not. Bedtime is 11:30. And then they get up 5:30. I was talking to this girl who lives in Oakwood. She's a sophomore there right now. She came home from January. We met. And she was like, yeah, one of the best things I think that you're kind of forced to learn is how to cope with not enough sleep. And she's like, it's not necessarily healthy, but I feel like it's a good life skill. I was like, what? She's right.
Maybe I should have applied that. It would have been one thing I'm more getting prepared for.
I'm good at sleeping for the last possible second. You're running very fast.
Yeah, no, I can't believe you did that today.
No, I opened my eyes at 8:38 and left by 8:40. So I'm just glad I wasn't completely late, I woke up at 8:50, I was like, oh.
Just the physics stuff.
Yeah, everybody just was going on over here. That's what I did.
Also, I don't know if you saw, but I tried to FaceTime you when you went outside because Joe and I were like, we should have followed him out. We'll just FaceTime him. We wanted to see your reaction.
Yeah, that's why I was like, huh? But I didn't actually hear my phone loading. It was just afterwards.
And then I tried to call your mom, and she also didn't pick up.
She was FaceTiming my dad.
Oops.
Wait, was that scholarship thing a surprise, or did you get there?
I had applied to it. I knew it was coming soon,
But my mom was being all cryptic about it, saying like, "Oh, meet me out at your car when you're free."
No, I mean the one you guys got extra.
Oh, the one for swim? Yeah, no, I didn't know about that.
Are we gonna have a scholar athlete banquet this year?
Maybe
Wait, what?
scholar athlete banquet.
Something we didn't have last year.
Like when you have a varsity letter and like above a 3.5 or something, you get a scholar athlete award. You have one. We just didn't have the banquet last year because of COVID.
I never even heard of that.
Well, the only reason I know about it is because like older siblings. I had to go to my sisters.
Also, I thought I got that GWAP award last year. I didn't only get the seniors this year.
I don't know.
Maybe I didn't get it last year, but I thought I did.
It's like, so the scholar athlete banquet's like, it's like a big, it's like imagine the normal like swim banquet, but like for all sports, like.
Oh, where is it?
It's usually in Trent.
They did it during
like
school.
Yeah, does everybody go? I feel like I do.
No.
Yeah. Yeah, during school and everybody lost their classes.
What?
Yeah, that was an underclass thing. Remember that?
That's the scholar award. That's not the scholar athlete. The scholar athlete is something else.
That was so dumb. I don't know why I did that. That was like,
Boring as hell.
yeah, just walk from stage.
And then you got like this dinky little medal.
Oh yeah.
And then they give you letters.
Oh yeah, that academic letter.
No.
Yeah, we were talking about that yesterday.
Yeah.
You're complaining.
I got it out. I got all my crap out yesterday. I just have it in a box in my room. Like all my letters and stuff.
My mom has a like box hanging in our family room that has all my letters and stuff.
I just in the bottom of my closet. That is where I added the crap I got last night. Like, back to the box.
You're gonna hang up the 4-year one?
No.
Really?
Dude,
Go on and
my
wait so long.
bedroom is already being taken apart, okay?
That's
There's
fair.
nowhere for my stuff to go. My
No,
dad,
I'm hanging it in our freaking living room.
my dad already got rid of my bed.
What?
What? Yeah. Where do you sleep? On the couch in the basement. Joe! That's where I slept before, I'm not gonna lie. But, they're ready.
Is the same thing with your mom?
No. She's more sentimental. But, still. I still need to rid of a lot of crap. It's kinda weird. You know?
Yeah, I know.
Plus I have like a jillion swim shirts. Even after I got rid of like 30 of them because I made them a quilt.
Uh-huh.
You're making.
I still have well my grandma. Yeah.
I like that.
I still have a bajillion shirts that I don't wear but I can't get rid of. You know. It's funny because I thought my dad was gonna be more like, can't wait to have you out of the house, and instead he's like, he'll look over at me and he's like, you're gonna come back every weekend, right? Yeah, my mom's afraid I'm never gonna come back to visit her. I'm like,
It's gonna be a little hard for you.
what?
It's gonna be a little hard for you.
My dad's like, I'm gonna come visit you.
My brother, he keeps saying, like, my dad rather have this plot to, like, appear in random places when I'm there. So, like, I think I saw them. Like, I really didn't. It's like, he'll just head over you, like, behind something, like, staring at me, and I'll be like, oh. They also go camping a lot. And he's like, if you get in, like, on our induction day, we're gonna go over there and we're gonna camp a week before induction day, and we're gonna be there. I was like, what? He's not kidding. I've never out there, actually.
Yeah, my dad's just like, I know where you live, so if you don't come home, I'll come to you. And I'm like, Jesus.
See, I can go somewhere they can't. Lucky. Also, they won't visit.
That's gonna be like a 5-hour drive for me, so they will visit, but not often. Probably.
Atlas is like 9 hours away.
Yeah. Yeah, that's rough.
It's not
Your backup
super
plans.
far. Though.
Your backup plans in Hawaii. So how far away is that?
Oh, way, way farther. Yeah. My backup, I'll probably go to like Ohio, Wesleyan, or like. I don't know. I don't want to.
How far away is West Point?
It's far. It's way up there in like northern New York.
It's way up there and then north.
Yeah, basically Canada.
My mom grew up north of Canada.
What?
The city she lived in, like, and there's Canada that like juts down under the city that she lived in.
Bruh.
So she always likes to say that she grew up in Canada.
In Michigan or?
Yeah, in Michigan.
644 miles, right?
644 miles.
It's a 15-hour.
Yeah, yeah. That's what I'm saying. I think I made it to, when we drove to Napa the first time, it was like 8.5 hours. Pretty sure.
Just depends on how much you
It's
speak.
also probably nicer there most of the year.
Oh yeah, way nicer. God, I cannot imagine. Plus the hills. I don't know why you want to like. I know they're gonna make y'all run, and we get nice flat terrain to run. Y'all are gonna be running mountains. Oh,
About for you.
what's her name? What's the
You'll probably have to
your
run
liaison's
last
name?
to there.
Yeah. Okay, when I was talking to her, I had that like 4 hours in call with her. She was telling me how she did cross country all through high school and she ran the cross country team when she, or maybe she was doing the cross country or something. And as soon as she got there, she like quit. First day, she's like, I'm not ready to do this now.
I would imagine it's plus mileage though. Like you guys might have to run further to run flat land.
Probably not. Although from what I've heard from people who've gone through it, whenever they go distances, it's only like 6 miles tops, and they don't go super fast.
That's not that hateful.
That's not bad at all.
I mean, I don't want to run 6 miles, but I could.
But with the giant group of people,
Yeah.
so much
You
easier
Billy?
than running by yourself. Oh yeah. Yesterday I was like the second one in my class. It was so weird. Not doing that again. Alright, have a good weekend, guys. You too,
Sure.
Joe. Love you. Yeah.
See you, Johanna.
See ya.
So, you know, I said, they update the mission portal on Friday.
They do?
Well, yeah, that's what they do.
Okay.
Or before Friday or whatever.
Hmm.
I can look at it today, and if I don't see something, I'm just gonna have no.
You're not what?
I won't get a notification that I did, only if I can.
That's so annoying.
Yeah, because they could give me one at any time for something else.
Yeah.
See ya.
See you, Jimmy.
Wow, imagine me without a child. Imagine that. Emily? You like to think so? Not right now.
Yeah, okay.
No, like you got
Do you want there, or are you gonna be okay?
I should be okay.
Okay.
I think I should be okay.
All right. You can leave stuff in here. I can move it to the back if you want.
It's okay. My mom's gonna come pick me up.
Okay.
So I should just take it with me.
Have fun.
Thanks.
Uh-huh.
It'll be a blast.
Always is.
I'm gonna go home and nap.
Yep.
And then I'm gonna Alright. I'll see you Monday.
Yep.
Have a good weekend, Wally.
You too.
So I mean, if that's true, when are we gonna be at 50?
Yeah, no kidding.
Bye, Coach.
See ya.
Have a good weekend.
You too. Oh, that lady called me about her bathroom.
Oh, did she?
Yeah, I can call her back this afternoon.
Wally, Wally, Wally.
What's up, Snyder?
Not much. How you doing today?
What?
How are you doing today?
I'm pretty good.
Right.
Yeah.
Do these have to get sewn on?
Yeah. I mean, they do it for you. You just bring the letter and the numerals, and they do it.